There is a difference between inverse function and inverse set function. These are very different concepts, but we often use the same notation. And that leads to a lot of confusion. We will understand this distinction using a problem. F inverse A union B and F inverse A union F inverse B. We want to relate these two sets, and I'll explain in a moment why this is a set and why this is also a set. These two objects that I have written here, both of them are two sets, and I would be able to compare between them. I mean, I could say that this one is larger than this one. I might be able to say this one is smaller than this one. It might so happen that these two sets are actually equal. So we would understand a lot about the meaning of sets and how functions work. Okay, so let's quickly define what a function is. Now, most of you know about this, but I'll take a little time to do it. A function is an input-output machine, of course, and it takes in some input and it gives out some output. I'll give you a quick example. Squaring. Maybe the function, all that the machine does, it squares the input. So if the input is 2, the output is 4. If the input is -2, the output is also 4. So the output is same. Okay. So it may happen that two inputs give you the same output. Two inputs, two or more inputs may give the same output. That's all right. But what is not all right is one input giving multiple output. So this is not allowed. We have a different name for this kind of a scenario, and this is known as a relation. So I'll give you an example so that you understand this very clearly. Suppose again we have an input-output machine, but this time the input is a person and the output is the children of the person. So maybe this person is your mother and the output is the children of that woman. So give output the children. Now if there is only one child, then we have no problem. Then we have one input and one output. However, if the mother has more than one child, then we will have multiple outputs coming from the same input. We do not consider this case. This is not a function. By definition, we have a separate name for this kind of situation. By definition. So a function is an input-output machine. A function is an input-output machine that gives only one output for every input. That gives only one output for every valid input. Okay, so this is the definition. Of course, this is very different than saying that input 1 and input 2 giving the same output. That's all right. Why? Because input 1 has a single output. That's all we want, that input 1 has a single output. But different inputs can give the same output. That's okay. This is an okay situation. Okay. All right. Great. So now we understand what is a function. We can now go ahead and draw two blobs. This blob will have the collection of all inputs. And this blob will have the collection of output. So remember, suppose a function is squaring. Then the input could be 2, -2. I can choose to put in other input values as well. If I do not, that's also all right. So this is a set of objects. This set is known as the domain. Now the output is, in this case, for both of them the output is 4. So this is the codomain. Actually, codomain can have more than just 4. It can have, let's say, 1, 5, 7 and so on. 4 is the range. 4 is the range. So I can choose codomain to be any collection of values, and range is usually a subset of codomain. Range is a subset of codomain. So range is the collection of actual outputs in some sense. Okay. All right. Now let's look at this particular situation one more time. We have two input values, 2 and -2. We have one output value in the range, which is 4. So this is domain. This is F. This is codomain. Okay. So this is a valid function because 2 gives out a single output, which is 4. -2 gives out a single output, that is also 4. So this is a valid function and we call it squaring. And now we come to the definition of F inverse. That is, we want to reverse the arrows. Now you immediately see the problem. This becomes your domain because in the reverse direction, this is your set of input now. And this is your output set. So this becomes range. Right? So what is the problem? The problem is that 4 gives out 2 outputs. 4 gives 2 outputs, 2 and -2 in the inverse direction. So if we reverse the arrow. But this is not allowed. So we say F inverse is not defined. Because one input gives 2 outputs. So let me define the inverse function very clearly. This is a definition. If f of x, x is the input, is equal to y, which is the output, then define f inverse y is equal to x. So just f inverse, you can think of it as another function which when takes in the output gives you the input. But in some situation this may not be a function. Why? In our previous example, f inverse 4 is 2, f inverse 4 is also negative 2. But two outputs are not allowed. So we understand that this is not a function. F inverse is not a function in this case. But f inverse is a set function. Now let me explain to you what is the difference. We again take 2 and negative 2. And we again take 4 here. This is the function f. This is domain, this is range. Now I'll define a function f inverse not in this direction, but from the powered set of the set R. So I make a new set which is a power set of R. What is the power set of R? It is the collection of all subsets of R. So now we have phi, which is the null set. We have the singleton set 4. Similarly, we have in D, instead of taking D, we take the power set of D. So what is the power set of D? It contains phi, it contains singleton 2, it contains singleton negative 2, it also contains 2 comma negative 2. Now notice that we can define a function in this direction. We can call this function f inverse, but this function takes in elements of the power set. So if I take 4 as the input set, this is an input set, then the output is just this, the set of 2 comma negative 2. So this is well defined now. So the f inverse is not well defined from R to D because 4 was going to 2 places, 2 and negative 2. F inverse is well defined from the power set of R to power set of D. Why? Because then the singleton set 4 gives a single output which is 2 comma negative 2. So you might say, why are we using the same notation from, okay, so this is the different direction, so this is R, okay. So why are we using the same notation for the actual inverse function from between the sets and the inverse function between the power sets? Why should we use the same notation? Actually, we should not. But unfortunately, most mathematics books use this particular notation, and therefore people have continued to use this notation. We should not have used the same notation for the inverse function and inverse set function. Very different things. Okay, now that we understand what is an inverse set function, can you show or can you find a relation between F inverse A union B? So if this is D and this is R, if this is a subset A of R, and if this is a subset B of R, then you can take the inverse image, maybe this one, inverse image of these two subsets, or you could have individually taken the inverse image of A and inverse image of B and made their union. So inverse image of A would be something like this maybe. Inverse image of B would be something like that. And if you union them, they will be union of two sets in the domain set. How are these two quantities related? So think about it. In the next video, we will discuss this and we will understand how to tackle this beautiful problem from set theory. If you know how to do this, write a proof in the comment section. Thank you for watching.